Everything in the universe is ordered. Everything is bound together by one force. Gravity. Everything happens for a reason. Isn't that wonderful? Newton described how gravity acts, and he explained why, and he was right, but he was worried, because you can't touch gravity. You can't see it. And Newton struggled with this. He worried and he doubted.
So, this is where J.J. Thomson discovered the electron, and where Rutherford split the atom. You know, one of the great rewards of this job is one never knows from where the next great leap forward is going to come, or from whom.
That's right, Murph. Murph, look at me. I can't be your ghost right now. I need to exist. They chose me. Murph, they chose me. You saw it. You're the one who led me to them.
It's called general relativity. It's a theory of gravity and everything. He's done it. Let me just show you.
What are you doing? Have you gone mad?
Dice on the other end. Pick it up. Pick up the tablecloth. Space. The tablecloth is space. The sun. What's happening?
What?
What's happening with the sun and space?
Well, the bread is sinking into the tablecloth.
The sun makes a shape around it in space.
Yes. Now, what happens if I do this? It wants to travel in a straight line, but it can't. Why not?
Because the bread's making a shape.
The apple follows the curves made in space.
Yes. Yes, space is shaped. And that is how gravity works. Space tells objects how to move. Objects tell space what shape to be. And there's a way to prove it. When starlight comes near to the sun, what will happen to it?
It'll bend.
Yes. That's what he says. That's what Einstein says. Starlight will bend.
Space is shaped. Space is full of curves and dents and wonderful shapes.
The comparison plate is in position.
No. We should do this in public. We should share this with anyone who wants to witness it. Right or wrong, this moment is for all of science.
If the stars on this photographic plate of the eclipse overlap with the comparison plate, Einstein is wrong and Newton's theory holds. If there is a gap between the two images, then the sun's gravitational field has shifted the star's position and we have a new theory of gravity.
A gap.
Einstein.
A star, more than 3 times the size of our sun, ought to end its life how? With a collapse. The gravitational forces of the entire mass overcoming the electromagnetic forces of individual atoms and so collapsing inwards. If the star is massive enough, it will continue this collapse, creating a black hole, where the warping of space-time is so great that nothing can escape, not even light. It gets smaller, smaller. The star, in fact, gets denser as atoms, even subatomic particles, get literally crushed into smaller and smaller space. And at its end point, what are we left with? A space-time singularity.
Amelia, be safe. Give my regards to Dr. Mann.
I will, Dad.
It looks good for your trajectory. We've calculated 2 years to Saturn.
It's a lot of Dramamine. Look after my family, will you please, sir?
We'll be waiting for you when you get back. Little older, a little wiser, but happy to see you.
I understand. Just getting to it.
Come in, Stephen. I know it's something we were all worried about initially. And you, Roger, I know you had some reservations about it then. It's the early days. Common in anything. Yes. Absolutely. Very well, very well. Well said. Welcome, Stephen.
Morning.
Would you like to take a seat?
No, I'm fine, thank you.
You're sure?
Yeah.
So, Stephen, in summary, as we know, Chapter 1, full of holes, lacks mathematical support. Professor Thorne?
Chapter 2, not really original. Uses a lot of Roger's ideas.
Well, at least you run with them. Chapter 3, too many unanswered questions?
I agree. And then, of course, we have Chapter 4, this black hole at the beginning of time.
Space-time singularity.
Indeed. It's brilliant. Brilliant, Stephen. Superb. Therefore, all there is to say is well done. Or perhaps I should say, to be more precise, well done, Doctor.
Bravo, Stephen.
An extraordinary theory.
Thank you.
So what next?
Prove it. To prove with a single equation that time had a beginning.
Everybody ready to say goodbye to our solar system? To our galaxy. Here we go.
I will write a book.
About what? Time.
Time. What is the nature of time? Will it ever come to an end? Can we go back in time? Someday these answers may seem as obvious to us as the Earth orbiting the Sun. Or perhaps as ridiculous as the Tower of Tortoises. Only time, whatever that may be, will tell.
So the lost communications came through.
How?
The relay on this side cached them. So years of basic data, no real surprises. Miller's side has kept pinging thumbs up, as has Dr. Mann's. Edmonds went down 3 years ago.
Transmitter failure?
Maybe. He was sending the thumbs up right until it went dark.
But Miller still looks good, though, right? Because she's coming up fast.
Mm-hmm.
With one complication. The planet is much closer to Gargantua than we thought.
Gargantua.
It's what we're calling the black hole. Miller's and Dr. Mann's planets both orbit it.
And Miller's is on the horizon?
Oh, it's a basketball around a hoop. Landing there takes us dangerously close, and a black hole that big has a huge gravitational pull.
Look, I could swing around that neutron star to
No,
decelerate.
it's not that. It's time. The gravity on that planet will slow our clock compared to Earth's drastically.
Oh, how bad?
Well, every hour we spend on that planet will be 7 years back on Earth. Well, that's relativity, folks.
Einstein's theory revealed that space itself, the entire universe, everything, wasn't just unimaginably large. It also had a shape and structure. It was malleable. Everything could be bent and warped.
Go, 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 go. 7 years per hour here. Let's make it count.
Decades.
What happened to Miller?
Judging by the wreckage, she was broken up by a wave soon after impact.
How's the wreckage stay together after all these years, huh?
Because of the time slippage. On this planet's time, she just landed hours ago. She probably just died minutes ago.
And now we're stuck here till there won't be anyone left on Earth to save.
I'm counting every minute, same as you, Cooper.
Is there any possibility? I don't know, some clever way we could maybe, I don't know, jump in a black hole, came back to years. Don't shake your head at me.
Time is relative, okay? It can stretch and it can squeeze, but it can't run backwards. It just can't, right? The only thing that can move across dimensions like time is gravity.
Okay. The beings that led us here, they communicate through gravity, right?
Yes.
Could they be talking to us from the future?
Maybe.
Okay, if they can.
They are beings of 5 dimensions. Right? To them, time might be another physical dimension. To them, the past might be a canyon that they can climb into, and the future, a mountain they can climb up, but to us, it's not, okay?
My daughter was 10 years old. Couldn't teach her Einstein's theories before I left.
Couldn't you have told her you were going to save the world?
No. When you become a parent, one thing becomes really clear. And that's that you want to make sure your children feel safe. And it rolls out down a 10-year-old. The world's ending.
Hello, Rob?
I've waited years.
How many years?
By now it must be.
It's 23 years, 4 months, 8 days.
Doyle?
new theory. Reality's different.
Amelia, your father solved his equation before I even left.
Then why wouldn't he use it?
The equation couldn't reconcile relativity with quantum mechanics. You need more.
More what?
More data. You need to see into a black hole. The laws of nature prohibit a naked singularity.
Romley, is that true?
If a black hole is an oyster, then the singularity is the pearl inside. The gravity's so strong, it's always hidden in darkness, behind the horizon. That's why we call it a black hole.
Okay, but if we see beyond the horizon...
We can't, Coop.
You were my ghost.
Cooper. Cooper. Come in, Cooper.
Sarge,
Roger that.
you survived.
Somewhere in their fifth dimension, they saved us.
Who the hell is they? And just why they want to help us, huh?
I don't know, but they constructed this three-dimensional space inside their five-dimensional reality to allow you to understand it.
Hell, that ain't working.
Yes, it is. You've seen that time is represented here as a physical dimension. You have worked out that you can exert a force across space-time.
Gravity. To send a message.
Affirmative.
Gravity can cross the dimensions, including time.
Apparently.
Do you have the quantum data?
Roger, I have it. I am transmitting it on all wavelengths, but nothing is getting out, Cooper.
I can do this. I can do this. You told him I like farming. It was me, Murph. I was your ghost.
I know. Nobody believed me. But I knew you'd come back.
How?
Because my dad promised me.
I'm here now, Murph. I'm here.
Can you hear me?
Now you are recognized everywhere. How do you deal with all the attention?
I was stopped recently by a tourist in Cambridge who asked if I was a real Stephen Hawking. I replied I was not, and said the real one was much better looking.
Professor Hawking, you have said you do not believe in God, but a philosophy of life that helps you.
It is clear that we are just an advanced breed of primates on a minor planet, orbiting around a very average star in the outer suburb of one among 100 billion galaxies. But ever since the dawn of civilization, people have craved for an understanding of the underlying order of the world. There ought to be something very special about the boundary conditions of the universe. And what can be more special than that there is no boundary? And there should be no boundary to human endeavor. We are all different. However bad life may seem, there is always something you can do and succeed at. While there is life, there is hope.